Wearable apps can send messages to their paired handheld devices using the Google Messaging API. In this demonstration, I'm using a Nexus 5 that's connected to an emulator. Notice that I have the Wear application open and I'm verifying that they're connected together. I'll be working in a project named Connect Devices. And as before, there are two modules, the mobile module for the handheld application and the Wear module for the watch application. And I'll start in the Wear module's main activity class. In this class, I've already declared a couple of important fields. A node will represent the phone that I want to communicate with from the watch, and the Google API Client class will be used to connect and to send messages. The Google API Client class is the same class I used in a previous course on working with the Google Maps API. It's a unified client that works with all APIs that are a part of Google Play services. I also have a couple of constants that I've declared. Wear path will be used to synchronize messages between the two devices, and wearable main will be used as a log tag, so I can use logcat debugging. My first step is to instantiate my Google API Client object, and I'll place the code here in my onCreate method. I'll start with mGoogle API Client equals, and then I'll use a class named Google API Client.builder. I'll pass in this as the context, and then I'll call a series of methods to configure my API Client object. First, I'll indicate which API I want to use with .addAPI, and I'll use a constant named wearable.api. Next, I'll set up some callback methods. When I try to connect to an external node, I'll be notified through a set of callback methods indicating success or failure, and I'll need to implement a couple of interfaces for that. First, I'll call the method .addConnectionCallbacks, and I'll pass in this, meaning that I want to implement the methods for these callbacks in this class. Then I'll call .addOnConnectionFailedListener, and this interface defines a method that will be called if I have a failed connection. And once again, I'll pass in this. Then I'll call the build method, and that will create my API Client object. Next, I need to implement my interfaces and callback methods. I'll use some shortcuts in Android Studio. I'll go to the first method I'm calling, addConnectionCallbacks, and place the cursor after the word this. Then I'll use an intention action and say that I want this class, main activity, to implement the required interface. That opens this dialog, and I'll accept both methods that are going to be implemented and press enter or return. That creates the two methods onConnected and onConnectionSuspended. Now I'll do the same thing for the second call. I'll use an intention action, and I'll implement the required interface and accept the methods, and that creates a method named onConnectionFailed. Up at the top of my class definition, I now have this implement statement, and it's referencing the two interfaces that I'm implementing, connection callbacks and onConnectionFailedListener. Next, I'll add code to actually connect to the external node. I'll do that in the onStart method. This is an override of the activities_onStart method, and here I'll call mGoogle API Client.connect, and then I also need to clean up the connection as the activity stops, so I'll implement onStop and call mGoogle API Client.disconnect. I'm almost done, but I have some critical work to do in the onConnected method. When you try to connect over the wearable API, you have to find out which node you want to connect to. There could be multiple nodes out there. For example, there could be multiple phones in the vicinity, but you'll only be connected to one of them. And there could be something called a cloud node, if your application does any cloud communications. You need to figure out which node you want to communicate with, specifically the paired phone. And here's the code you'll need to do that. I'll use a class named wearable.nodeAPI, and I'll call its method .getCollectedNodes. This requires an instance of Google API Client, and I'll pass in the object that I've already set up. Next, I'll call a method called setResultCallback. This method sets up a callback method so that when you're connected, you'll be able to get back a set of nodes and loop through them and find the node you want to communicate with. I'll pass in a new instance of a class named ResultCallback, and that generates a whole bunch of code. The ResultCallback has a generic type of getConnectedNodesResult, and this callback method on result receives an instance of that class. The default name is a little long, so I'm going to shorten it to just nodes. And then within this method, I can find the node I want to communicate with. The getConnectedNodesResult object has references to one or more nodes, and it's returned to you in a list calling a method named getNodes. So I'm going to loop through that list with a for each block. Each item I receive will be an instance of the node class, and I'll just name that nodes, and I'll indicate the collection I'm iterating through with nodes.getNodes. I'll close up this code a little bit to make it easier to read. And my next step is to examine each node and check for two things. I'll use a conditional block, and first I'll make sure that the node object isn't null, and then I'll make sure that it's nearby with node.isNearby. Now again, a phone that you're actually connected to through Android Wear will report that it is nearby, and a phone that you're not connected to will report that it's not nearby. So if both those conditions are true, then I can say that's the node I want to use. Up at the top of my code, I declared the mNode object, and I'm going to fill that in now by saying mNode equals node. And I'll also output a logcat message with log.d, and I'll use the wearable main tag for this, and my message will be connected to, and then I'll call a method of the node object called getDisplayName, and that'll tell me which phone I've actually connected to. Now at the end of the for loop, I'll add another conditional block, and I'll ask whether mNode is null. And if it is, then I'll use a logcat message, and this time the message will be not connected. So let's review all the code before we test. In the onCreate method, I created my Google API client and said I wanted to use the wearable API. I implemented the methods I needed to handle the results of connecting, and then in my onStart method, I'm connecting. So let's run the app. I'll make sure that I'm using the Wear Edit configuration. If you try to load this application onto your mobile device, your cell phone, it'll load, but it won't work the way you expect. After a moment, the app is loaded on my watch emulator. And I'll come back to Android Studio, and I'll look in my logcat output, and I see connected to Nexus 5. So I've had a success. I'm connected to the phone, and I'm ready to move on to the next step, sending a message. Now, if you have trouble with this, go back to your phone and your device and make absolutely sure that they're connected together. You can do that through the Android Wear application on the phone. If you see connected, then the two should be able to recognize each other over a Bluetooth connection. And again, it should work with either an emulator or a physical device. I've added code to my wearable app to connect to the node, that is, the phone that's paired with the watch. Now I'm ready to send a message to the phone. I'm working now on a version of my project named Send Message. It picks up where the last project left off. And first, I'm going to handle the click event that happens when the user touches a button on the watch app. When the user touches one of these buttons, that will call the method buttonClickHandler. Now, this method is registered in the onClick event handler in each of the buttons. They all call the same method, but they all have different text values that are based on string resources that are stored as part of the app. They're named London, Hong Kong, Paris, and San Francisco. But these values, in turn, match values that are in the dataset used by the handheld application. This class, Data Provider, defines all of that data, and you'll see exactly the same strings here: London, Hong Kong, San Francisco, and Paris. So that's how the two apps are matching up with each other. My job in the buttonClickHandler method is to get the text from the button that's been selected and then send that string to the phone. To do this, I'll create an instance of the button class, and I'll name it button, and I'll just get it from the view argument. And then I'll use an intention action to cast that as the button class. Button is a subclass of view, but the button class can tell me what the text value is. Then I'll create a string variable that I'll name city, and I'll get its value by calling button.getText_string. And then finally I'll send the message, and for this purpose I'll call a method that hasn't been created yet, and I'll call it sendMessage, and I'll pass in city. Then I'll use an intention action and I'll create that new method. And this is where the real work will be done to send the message to the phone. Now I'm going to collapse some of this code that's surrounding this so I can see the code I'm working on a lot more clearly. My first step is to make sure that I have a node that isn't null and an API client that isn't null. So I'll set up some conditional code, and here's my expression. If mNode not equal to null, and if mGoogle API client not equal to null. So if I get this far, then I'm ready to send a message. I'm going to use the class wearable.messageAPI, and I'll call a method named sendMessage. The sendMessage method takes 4 arguments: the Google API client, 2 strings, and a byte array. The API client is easy. That's my mGoogle API client field. Now the second argument is the identifier for the node you want to communicate with, and you can get that from mnode.getID. The third string is a tag that you'll attach to the message. This is how you're synchronizing the message you're sending from the watch with the message you're receiving on the phone. And this is where I'll use my other constant that I named wherePath. And finally, you'll pass the actual message, which needs to be an array of bytes. And I'll get that with the city variable, and I'll call getBytes. Now the sendMessage method returns an instance of pending result. And from that point, I can set up callbacks. I'll call .setResultCallback. And just like I did last time, I'll pass in a new instance of result callback. And this time, in my onResult method, I'm getting something called sendMessageResult. I'll expand the width of my editor so we can see all that code. And this is the object that's being returned to me. Here, I'll use another conditional block, and my expression will look like this. If not, sendMessageResult.getStatus.isSuccess. Then I'll use a logcat message. I'll pass in wearable main as the logging tag, and I'll pass in failed message, and then I'll append to that sendMessageResult.getStatus.getStatus code. If you want more information, you could use getStatusMessage. Then I'll add an else clause, and once again I'll use a logcat message, and this time I'll output the message succeeded. So let's once again look at the chain of calls. When the user selects a button on the watch, that'll trigger button click handler, and I'll extract the string from the button that was clicked. I'll then call the sendMessage method. Within that method, I make sure I have a valid node and a valid API client, and I send the message. I indicate the API client, the node, a constant to synchronize the messages together, and the message as a byte array. And then I set up a callback method so I can find out what happened. I'll run the app on the watch. And again, make sure you're using the wearable edit configuration. When the app appears on the watch, I'll touch one of the buttons, and I see the logcat output, message succeeded. So far, so good. I'm successfully connecting to the phone and sending the message, but now I need to receive and interpret the message on the phone, and I'll show you how to do that in the next video. So far, I'm sending messages from the wearable app to the handheld device, and now I'm ready to receive that message and do something with it. In the current version of the app on the phone, the user can select an item from a list, and that takes them to a detail activity which displays the details they've requested. Here's how that's working in the current version of the app. In the main activity, I've set up a list view on item click listener. When the user touches an item in the list, that creates an intent to open the detail activity class. Then an extra string is passed into the intent, passing in the name of the city that the user selected. Then I'm starting the activity. In the detail activity, I'm getting that value by calling getIntent.getStringExtra using the same string, city, and everything from there is simply retrieving the data and displaying the details. My goal now is to do exactly the same thing when I receive a message from the watch. Remember, in the wearable app, I'm sending the name of the city that's being requested. So to do that, I'm going to use a service. I've already created the class listener service from where. Right now, it doesn't have any effective code, but it does have the constant where path that has exactly the same string as in the wearable application. I'll correct this and make sure that it's all uppercase, like all good constants should be. In order to receive the message, I'm going to extend the class wearable listener service. And then I'm going to override a method of that class named onMessageReceived. So when a message is sent from the watch to the phone, this method will be triggered. When the message comes in, first I want to make sure it's the message I'm expecting. So I'll use a conditional block, and I'll examine this message event object. The message event class is a member of the Google Play Services library, and it has methods named getPath and getData. My condition will be messageEvent.getPath.equals, and then I'll use my constant wherePath. So if that's true, then I know I received the right message. Then I'll get the data. I'll create a variable named city, data typed as a string, and I'll get its value from new string, and I'll pass in messageEvent.getData. The getData method returns a byte array, and then I'm constructing a string from the byte array. Next, I'll create an intent, but the code here is almost exactly what I was doing before in the main activity. So I'll come over here, and I'll select and copy this bit of code, and then I'll come back here to the listener service and paste it in, and I'll get rid of some code I don't need. I don't need hotel location, and then I'll modify the rest of the code. When I create the intent, I'll pass in this as the context. But then once again, I'm opening the detail activity. Next, for the city, I'll pass in my city variable that I just created. I need to add a bit of extra code here, a couple of flags that I'll attach to the intent. This will ensure that the activity can open even if the application isn't already open on the phone. It'll look like this: intent.addFlags, and then I'll pass in two flags. The first is called flag activity new task, and that makes sure that the detail activity can open even if its parent activity isn't already open. Then after that flag, I'll put in a pipe character to separate the flags, and then I'll pass in flag activity clear top. Now that means that if the activity is already open on the phone, it'll clear it from the top of the stack and then rebuild it with the new data. And then finally, I'm starting the activity. So that's all the code I need to receive the message. But now I need to register this service in my application manifest. So I'll go to my app manifest, and I'll place the cursor here, still within the application tag, but outside any of the activities. I'll create a service declaration, and I'll set its name to the name of my class, listener service from where. Next, I'll create an intent filter, and I'll give it an action. The action will be based on a string from the Google Play Services library. You'll need to type the entire thing without autocompletion, with com.google.android.gms.wearable, and then in all uppercase bind_listener. So this is basically saying that this service which will be set up as the application is installed on the phone, will now be listening for wearable messages. When the message comes in, that'll result in calling a method from this class, onMessageReceived. The message will come in as the message event object, and then I'll examine the message, get its data, and make something happen on the phone. Now, I'll make sure that I'm running this application on the phone, not on the wearable device. I'll select the mobile edit configuration, and then I'll run the app. I'll run the app on my Nexus 5. When the app opens, I'll now try to send a message from the watch to the phone, and there's the result. I see the detail activity open on the phone and display the requested data. I'll choose another hotel on the watch, and I see the desired result. Now, to make sure this is all working correctly, I'll exit the app on the phone completely by pressing the back button a couple of times, and then once again I'll click a button on the watch, and I see the requested detail activity appear, and I'll try another hotel, and once again I see that it works. So now I'm successfully sending messages from the watch to the phone and opening an activity on the phone when the message is received. There's a lot more work you can do integrating these two devices together. For example, you could learn how to display a simple wearable list on the watch, something that looks more like it belongs in a watch interface, and display the data that way. And you could even synchronize the data between the two devices so your only data source was coming from the phone. But these steps are enough to get you started communicating between the two devices, letting the watch control the phone through the Wearable Messaging API.